All right, so number 25, we have this cannon. So who's this guy? Jules Verne proposed sending men to the moon in 1865 by firing a space capsule from a 220-meter-long cannon with a final speed of 10.97 kilometers per second. So right off the bat, you got to pay attention to units. We have kilometers and meters. Are those going to work together? So what I would do is change one of them to match the other one. So let's take this 220-meter-long cannon, and we'll change it to 0.22 kilometers. 220 meters is the same as 0.22 kilometers. So let's put a dude inside the cannon. The length of the cannon, which we'll call x, is 0.22 kilometers. What's the starting velocity of this guy? V initial before being launched, 0. Now we're using kilometers here. We're kind of committed to that. Kilometers per second. The guy gets launched, and the final velocity, that's what they give us right here. The final speed, VF, as he leaves the cannon, is 10.97 kilometers per second, which is an insanely large speed. All right, the thing we're solving for is the acceleration of the guy well inside the cannon. Okay, so this can be solved with one of the motion equations. So you have to have the equations memorized for the quiz. What motion equation will solve this? I think there's only one that'll do it, and it starts with V final squared. It's the motion equation that starts with V final squared equals V initial squared plus 2AX. Okay, V initial is what? 0. Now notice I'm not plugging numbers in. Plug numbers in after you've done the algebra. Solve this for A. A equals V final squared over 2X. So V final is 10.97 kilometers per second, and make sure you square it, and then divide it by 2 times the displacement, which is 0.22 kilometers. Hey, now typically we're not in kilometers, but is this okay to be in kilometers here? Yeah, as long as your units agree, it's fine. Like here we have kilometers here, and we got kilometers there. If you would have taken this 10.97 and converted that into meters per second, that's fine also. As long as your length measurements, as long as the unit for length is the same, it's okay. Okay, so this gives us an acceleration of 273.5 kilometers per second squared, which is going to be equivalent to 273,500 meter per second squared. That's a huge acceleration. That's enormous. Okay, but did I do that correctly? Yeah, there's 1,000 meters in a kilometer. Okay, now see this part here? It says a human can stand an acceleration of 15 g. What is 15 g? Well, what is 1 g? 1 g is what? 9.8 meter per second squared. So how many g's would this be? This number down here, 273,500 meter per second squared. That's a lot of g's. You know what? Let's just round this to 10. Let's just say that 1 g equals 10. So then how many g's would this be? This would be 27,350 g's. Just divide it by 10. So would anybody survive this cannon launch? No. A human can stand an acceleration of about 15 g's. So this would like disintegrate the person being launched. That's way too much of an acceleration.